பாரு என்ன பண்றேன். So this is the experiment, the reverse bias characteristics of VI characteristics of the Zener diode. So we are having the Zener diode here, and the same circuit diagram as the PN junction diode reverse bias. The anode of the Zener diode, which is this side over here, is connected to the negative, and the cathode is connected through the ammeter to the positive. So that means that the Zener diode is reverse biased. Now let us see how the voltage current characteristics is. So we will increase the voltage. So when we increase the voltage, so this is the reverse voltage. This meter shows the reverse voltage across the diode. This meter shows the reverse current across the diode. So we will increase the voltage. So when the voltage is around 1 volt, the current is 0. So we can just write it down. 1 volt, the current is 0. Then when the voltage is 2 volts, the current is still 0. So 2 volts also, the current is 0. Then 3 volts, the current is still 0. 4 volts, the current is still 0. So 3 volts also current is 0. 4 volts also current is 0. Now when we continue to increase, now around 5 volts, the current increases to 2 milliamps. So 5 volts, the current is 2 milliamps. Then we further increase the voltage. The voltage across the Zener diode stays, now it is at 5.1 volts. So 5.1 volts, the current is now 4 milliamps. Then I continues to increase the DC supply here. So actually here the DC supply is now 8 volts, but the voltage across the Zener is still at 5.1 volts. So the voltage across the Zener, we will note it down, which is 5.1 volts, and the current is now around 3 milliamps. No, sorry, 4 milliamps only. 4 milliamps. So then we will just increase it. We are now increasing the voltage from the DC supply. It is 10 volts, but the voltage across the diode, Zener diode, remains at 5.1 volts. So 5.1 volts, but the current is now 6 milliamps. Now still continues to increase. Now let us make it 15 volts in the RPS. The voltage is still 5.1 millivolts, 5.4 volts across the diode, and the current is now 10 milliamps. So we'll just increase the RPS voltage to 20 volts. The voltage is still 5.1 volts, and the current is now 15 milliamps. And still a little more increase up to 25 volts across the DC RPS, but the voltage across the diode is still 5.1. So we will write down only the voltage across the diode in the table, which is 5.1 volts. The current is now 20 milliamps. So this way we can see from this table that we have taken 12 readings. The voltage across the diode continues to be at 5.1 volts and the current starts to increase. This is because this is a Zener diode, and the breakdown voltage is 5.1 volts for this Zener diode. Therefore, after 5.1 volts, the voltage across the Zener diode remains constant, but the current increases rapidly. That means it allows the current to flow, but the voltage remains at 5.1 volts even when the RPS voltage is increasing very high. This makes the Zener diode useful for regulator purposes. That's why Zener diode is used as a voltage regulator, because the voltage across the diode remains constant even when the input voltage is increasing very more. That's all. Thank you.